Okay, today we will continue to review trigonometry on the calculator from accelerated geometry. So again, a lot of review when you guys first saw trigonometry in geometry. Okay, when we did that, we were using it to solve the triangle. In order to solve the triangle, you need to find all three angles and you need to find all three sides. So basically, find all the parts of a triangle. Here's our first example. We have to solve this triangle. We have to find a few things, but there are a few things that are given to you. We know the hypotenuse is 15. There's an angle here that's 70 degrees, and then this is 90 degrees. So they give you a few information. You have to look for the rest of the information. All right, the first thing that I'm going to solve for is the easiest thing. It's just this missing angle. Well, from the triangle sum theorem, we know that all three angles inside of the triangle must add up to 180. So if you do 70 and 90 and x, that will solve for the missing angle. And x turns out to be 20. So that was an easy one to find one of the angles. Now let's go ahead and find the sides. There's two sides that are missing. This side's missing and this side's missing. We're going to solve one side at a time. Let's go ahead and solve for this side. We'll call it x. To solve for x, you're going to have to set up a trig equation using SOHCAHTOA. All right, so you have to ask yourself, how does 70 degrees relate to the x, and how does it relate to the 15? And you should know that it is cosine. Cosine is adjacent over hypotenuse. So there's my setup. Cosine of 70 is equal to x over 15. Make sure your calculator is in degrees mode when you do this, otherwise you will get the wrong answer. But if you punch cosine of 70 into your calculator, you should get about 0.3420. And then to solve for x, just multiply both sides by 15. And there's our x. Fairly simple. Let's go ahead and solve for the other side. We'll call that one y. Now you have to ask yourself, how does the 70 degrees relate to the y and the 15? Notice the y is the opposite and the 15 is the hypotenuse. So opposite and hypotenuse means we're going to use sine. Sine of 70 is equal to y over 15. Again, on your calculator, punch in sine of 70 and you should get 0.9397, and then multiply both sides by 15. All right, and now we have successfully solved the triangle. We got all three angles and all three sides solved for. Let's do just one more example since this is review, so we don't have to do a lot of examples. Let's solve the triangle here. Notice there are a few things missing. We're missing this angle, we're missing this angle, and we're missing this side. Alright, so we have to go ahead and find all three of those. Let's go ahead and find the missing side first. Well, the last example we needed to use trigonometry, but you don't have to if you don't want to. You can always go back to what you learned in the 6th grade using the Pythagorean theorem. A squared plus b squared is equal to 0. A squared plus b squared is equal to c squared. You can still use that for right triangles, remember. So here it is, the Pythagorean theorem. 8 squared, 15 squared, subtract the 64, square root, you should get about 12.6887. All right, so you don't always have to use trigonometry. You can still use Pythagorean theorem if you can. Now let's go ahead and try to solve for the angles, one angle at a time. Let's go ahead and try to solve for angle A. Now you have to use some trigonometry. You have to ask how A is related to 8. Excuse me. And 15. 8 is the adjacent side, and 15 is the hypotenuse. So that means we're going to use cosine. From here, you're going to go ahead and punch in 8 divided by 15 to get 0.5333. All right, and at this point, you have to ask yourself, how do I solve for A? How do I get rid of cosine? Well, this is what we've been working for. To get rid of the cosine, you have to do what's called cosine inverse. So we've been working on the inverses. So on your calculator, though, at least you don't have to memorize the unit circle in this case. On your calculator, you're going to go ahead and punch in cosine inverse. Make sure there's a -1 there. It's on top of the regular cosine button, so make sure you do second and then cosine. And if you do that properly, you should get A is equal to about 57 degrees. All right. Cool. Now we're going to go ahead and solve for angle B. Here's angle B. Now your question is, well, now that we know A and we know 90, we should be able to use the triangle sum theorem to solve for angle B. And yes, it is true, you can, but that's too easy. Instead, we're going to go ahead and use trigonometry again to solve for angle B. I already clicked on it, so here it is. Angle B is equal to the 8 over the 5. That requires us to do sine. Again, 8 divided by 5. That's just 0.5333. And again, to solve for B, you have to get rid of the sine. And to do that, you have to do sine inverse. Sine inverse 0.5333. If you punch it in correctly on your calculator, you should get about 32 degrees. And then you can always check yourself. These together with the 90 degrees should add up to 180, or very close. And if you are very, very close, then you should be good. All right, we got a short lesson today. That's all we have. Go ahead and work on the homework.